I'm Rod. I'm the tech lead and eng manager for Google Fonts.
I'm Peter Constable. I'm a program manager at Microsoft.
And our friend Dominic is a software engineer on Chrome. He lives far away and was unable to join us. So we have a recording of him coming up later. So I'm going to talk a little bit about kind of what we mean by color fonts, because sometimes that actually gets lost. You'd think it was surprisingly basic, but. So if we say color font, what do we actually mean? I think we can start by maybe talking about what a non-color font is. So where it says, am I not color? This is not what we mean. This has kind of one monochrome color. It's not really defined in the font. It's whatever the user says it should be. Ignoring anti-aliasing, we just get one. And as I said, the font's not dictating it. So the end user gets a rendering in some color, but that didn't come from the font. The font really just defined where ink goes. So on this slide, lots of colors, but no color fonts in the sense we mean here. In a color font, you can use many colors in one glyph. And when you drop a glyph in, it isn't limited to just drawing whatever the text color happens to be. In fact, it might just ignore the text color entirely. Some color font formats can use it. And in some cases, you can actually change the entire color palette. So here, emoji being the most typical example. And you can see it didn't really respond all that much when I set one of them in the foreground text color kind of black and made the other one red. It just didn't do much of anything. So today, probably the #1 case you'll encounter color fonts for is emoji, but by far not the only use case. So here's one example I quite like. It's by David Jonathan Ross. It's called Bungee. It's a celebration of urban signage. It's free and open source on GitHub, and it leverages color. Here's another one that I think is quite cool, where Khalid tweeted about this. It's from the Amiri family, and it shows color being used for something more than emoji and kind of display faces. Like here, it's actually becoming a deep part of the text, and potentially you could imagine being able to assign the individual colors in here. So,
Can people see the colors on that?
yeah, hopefully that's coming across. So if we can get to the point where we have a widely supported good color format, my hope is that we'll actually see color get used much more widely. We'll see a proliferation of use cases beyond kind of emoji. People have been speculating about that for, as far as I could tell, at least 5 years, quite likely much longer. And Color V1 is available in Chrome Canary to experiment with. So why don't we have this today? I would say things kind of derailed a little when fonts came to color. So I think motivated by emoji and, oh no, we've got to ship something, everybody invented their own format, and none of them really make us entirely happy. We have 2 bitmap formats. One's by Apple, one's by Google. They just ignore everything that makes a font, and it's a bag of bitmaps that impersonates a font. If you scale them, they have bad edges, they're huge, they scale with the number of assets, even if they're very similar. The list of complaints kind of goes on. You want to make a variable font, let the user assign the colors, do hinting so it matches a pixel grid nicely, like all of this goes out the window. SVG, you could say, is better by, I believe, Mozilla and Adobe. You shove an SVG into the font, should be fine. You get vector graphics, you have kind of a great deal of flexibility in drawing things. Comes at the cost that you have to have an SVG engine, which is not true in all environments and may be a major investment. And it also doesn't really integrate with the rest of the font format. So if you want variable color fonts, they don't work so well if you're shoving SVGs in. You also don't really get hinting, you don't get a compact binary format. So Color V0, which was Microsoft's effort, is, I think, the best one. It said, fonts already know how to draw vector shapes. I'm gonna pull this down because I can hardly breathe. So we'll reuse the font's existing capabilities for vector shapes, and we'll say, okay, well, we'll just stack them up in some order. We'll assign them color. The big limitation is that you just get a flat color. So you can have variations here. You can have a colorful variable font. You can have hinting. You get compact binary. But your ability to paint is quite limited. And one of the strong points of fonts is they mostly work everywhere. If you're careful, you can build a font that you can pretty much install on any major platform. It'll work. Unless you have color, where random things support random subsets of the possible ways to do it. And we're left with emoji being the only widely adopted use of color fonts. And you'll note that those basically come with the platform. So you ship what works on your platform, and don't stress that if you take it anywhere else, it'll just break. So I'll pass it to Peter.
So we want to take a moment to consider
what if the world were different? What if we didn't have 4 different formats, each of which only works in a small subset of potential places? So what are things that ideally we would like to have in a color font format? Well, you want a lot of good graphic capabilities. Bitmaps are great for a designer because they can control every pixel as long as they're only interested in a specific size for that, because when you go to a different size, you want something else. So there's definite advantages to vector formats. Do you have a vector format that has a lot of capabilities? As Rod mentioned, for the color V0 format that Microsoft created, the design capabilities were limited. You can stack up these shapes, but each of them has just a single color fill, right? You can't do anything like gradients, for instance. So you want something that's got a rich set of graphic capabilities. And you want something that's extensible. If at some point there's some new graphic capability that you need, or you want to integrate some other functionality with the font format that's sort of independent of color, well, you want something that is amenable to extending new functionality later on. You do want it integrated with other aspects of the font format. So Color V0, because it's using the font's glyph outlines, hinting is already well integrated. If you want to hint your font, your color shapes are also going to be hinted. And then there's this technology that was introduced about 5 years ago called variable fonts. How many are familiar with variable fonts? About half the room. So variable fonts are a technology, the shortest way to describe them is it's a way of combining an entire family of fonts into a single font file. So the color format was the only one that really integrates with variations. Ideally, you'd have a color format that does do that, integrates with this other important technology that's part of OpenType. Something that has easy platform implementation. How costly is it going to be for a platform or an application developer to leverage the technology in their software? You also want compact fonts. One downside of the bitmap formats is, well, if you want more than one size, you have to have multiple bitmaps, and those sizes add up very quickly. One platform that, I won't name names, but you're familiar with it, they've got a color emoji font with bitmaps that is 200 megabytes. In terms of fonts, that is ginormous. And something that's good for font developers. Well, what does it mean to be good for a font developer? Well, it's something that's well supported in font development tools, but also something that will work everywhere. Because a font developer, when they create a font, unless it's something like an operating system font that only that operating system needs to support it, in general, a font vendor, they want to be able to sell their fonts to customers that are going to be creating content for use in any number of contexts. And so you want a font technology that is widely supported. So people don't have to worry about asking, well, if I buy this font, will it work in that browser? Will it work on that operating system? Just have it work everywhere. Those would be ideal. As we think about which of the color font formats are, lend themselves to getting towards that world, we've already talked about limitations of the bitmap formats. And so we've got these 2 vector formats now, the color format and the OpenType SVG format. And so there's these 2 perspectives. One is to say, well, we've already got color, can we add new graphic capabilities, extend it with new graphic capabilities? There's an alternate that says, well, we've got OT-SVG, and SVG already has lots of graphic capabilities. Why don't we just use even more of those capabilities and get that adopted widely? Well, I want to drill in for a moment to look in more detail at the SVG case. So there are pros and cons to SVG. One for font designers who are creating these color graphics, SVG is good because a lot of design applications do support export to SVG. So for instance, if people are using a design application like Figma or like Adobe Illustrator, they can design their graphic and then exported as SVG. And then it's just a matter of taking that SVG and embedding it into the font in the right way. So that's one advantage of the OTSVG format. It's got rich graphic capabilities. And supporting it isn't that costly, but an important caveat. It's not that costly to add support for it if you're in an environment that already supports SVG. So for example, SVG is used on the web, it's supported in browsers. If I'm a browser developer, it's probably not that costly for me to add OpenType SVG support. But if you're not already in an environment that has a need for SVG support, then supporting OTSVG has that additional cost. I need to interact with graphics libraries to do all the graphics functions, but in addition, I need to add an XML parser that understands the SVG language and all of the CSS that can go with it, right? So there is a significant additional cost. OTSVG also doesn't really integrate well with the rest of the OpenType format. For example, variations. There isn't any easy way to make the SVG glyphs in an OpenType font variable. And so that's sort of a showstopper. In a sense, SVG was really an entirely different technology that kind of got bolted on to the OpenType format. It doesn't really integrate it very well at all. SVG is definitely better than bitmaps in terms of size, but it's not as optimal as it could be. So for that reason, we wanted to take the first approach, take the color format and enhance it with additional capabilities. So we started with a set of design goals, build on the benefits of the original color format, things like having all of the shapes be defined using the additional TrueType or CFF outline formats. Add richer graphic capabilities. Gradients was the one must-have that really started the interest in this. But there are lots of other graphics capabilities that we could look at and say, can we add these things? It was desirable to have a set of capabilities that we knew would be widely supported in different platforms or in different graphics libraries to expedite adoption of the new format. We wanted something that would fully integrate with variations. So as I say, this is relatively new technology, but it's become a pretty important technology among font vendors. So we wanted something that as thoroughly as made sense could integrate with variations. And we also we had a goal to come up with a format that could be as size efficient as possible. So I've got a little comparison here of what you can do in Color V0 and with Color version 1. So in the V0 glyphs, you can see that there's all these different shapes, but each shape has a solid color fill. Whereas with version 1, you have shapes, but those shapes can have gradient fills, right? So that's a significant difference. There's going to be more that I'll talk about in a second. But let me just first talk about, okay, how does Color version 0 actually work? So suppose we wanted to make a smiley face. First, you'd start by creating glyphs for each of the shapes that you want to use in the smiley face. The smile, the background, a pair of eyes, right? And so then you start putting these in layers, starting at the bottom and adding things on top. And so we start with the bottom layer, which is the face, and we give it a color, a solid color fill. We make it yellow. Then we add the smile on top in the next layer, and we say this layer has uses a white fill. And then finally, we add another layer with the eyes, and we say this layer uses blue as its fill. There we've got our smiley face. For Color version 1, you can do all of those same things, but now I'm going to add in that we can, so I'll start with defining a set of shapes that I'm going to use, that I'm going to stack up in a set of layers. But now I can also define gradients that I will use to fill the shapes in some of those layers. So I'm going to define this orange-yellow gradient and then this dark blue, light blue gradient. So again, I'll start with a background layer that's got the background of the face, but now I'm using that gradient to fill the shape. I'll add the eyes, and in this layer, I'm going to use that blue gradient to fill the shape. Right, so you can see the little bit of highlight in the eyes. Well now, okay, since I've got that ability to the eyes, let me enhance it just a little more. I'm going to add one more layer with an even lighter blue to indicate a highlight on the eyes, reflecting some light source. And I add my smile, and maybe I added one more little thing over in the lower right to give a little more darkness, to add a little more depth. So the key difference here was that it was the same general concepts, but I've introduced the gradients that I can use to fill. So let me talk a little bit more about the kinds of gradients that are supported in the format. We've got 3 types of gradients that can be supported at this time. So there's linear gradients, which is, if you've done work with graphics software, you're probably familiar with linear gradients. You define a line, a color line, with some color stops at certain offsets on the line. But the color actually extends indefinitely in two-dimensional space. We have 3 different ways of saying how you extend the colors. So in this linear gradient, we use one of those modes, which is a pad mode. Whatever was the first color in the color line, everything before that uses that color. And at the opposite end, you use the last color to extend off in the opposite direction. So you continue the last blue, in one direction, you continue the last red in the other direction. Radial gradients are another format, gradient format that we support, although this is a superset of what you may have encountered with radial gradients before. The gradients are actually defined using a pair of circles. So in fact, what you're describing is a cylindrical tube. And the gradation of color happens along the length of that cylinder, right? Now, I can collapse one of those ends to a single point. So I create a cone, and if the center of that circle is inside the other one, then you have the more traditional notion of a radial gradient, where a gradation is radiating out from a central point. Here, the extend mode is a different one. It's what we call a reflect mode, where you've got gradation from the beginning of the color line to the end, and now as you start to extend, you use the same color line, but it's reversed. So I went from red to blue, now I'm going to go from blue to red, and then I'm going to reverse it again. So you go back and forth in the opposite directions of the color line. That's the second extend mode. Again, you're extending the colors indefinitely in the plane. Finally, the third type of gradient is, sometimes it's called a conic. We refer to it as a sweep gradient. So here you've got gradation of color sweeping around some central point. Right? Okay, so gradients are one of the important additional capabilities, graphic capabilities, that we're adding into the color table. And another important concept was reuse of components. So emoji are a great example of this. You've got all these cat faces, and all the cat faces are different, but they've got a lot of the same elements in common. The yellow head, the whiskers, the little stripes at the top of the head, the pink inside of the ears, those are exactly the same in all of these. So you don't want to create separate data for all of those. You want to reuse them in each of those. So reuse was an important concept. We were able to reuse, you might reuse a particular shape and whatever you fill it with. Or you might say, okay, I've defined a set of layers, a group of layers that have particular content in them. I want to reuse that entire grouping of data. Or maybe I've defined one color glyph that can stand on its own, but I want to reuse that as a component inside some other color glyph. So I can reuse the entire color glyph definition. So lots of different ways that we have for reusing data. Transformations are important. So we've here in this these clock faces, you see the hour hand is exactly the same shape, but it's rotated around at different angles. So can we reuse the shape, but then just apply a transform to give it a different orientation in each case, as opposed to creating an entire different glyph outline and separate fill for it. So that's exactly what we do here. So here we've got one set of data that describes all of the stuff that's the same in all of these clock faces. So there's the background with its gradient fill, the minute hand, the 4 cardinal points for 3, 6, 9, and 12. Those are all the same. And then we add one shape for the hour hand. We give it a green fill. But now when we use it in the different clock faces, we apply a rotation transform. So we reuse as much of the data as we can in all of these, but we leverage the transform to give us the thing that needs to be different in each of these clock faces. So there are several different types of transforms that we support, and the transforms can be applied to anything in the format that has geometric aspects. So it could be applied to the glyph outlines, it could be applied to the geometric aspects of the gradient. For instance, with the radial gradients, I said you define it with 2 circles, but I could apply a transform to those to make them ellipses, for example. Compositing and blending is another key area of functionality. Both of these involve taking two graphic compositions and combining them in some way. The key thing, the key distinction here, compositing is saying, well, I've got these 2 things that I'm going to combine. I've got a source A and source B. Which of the content in source A is going to be included in the result, and which of the content in source B is included in the result? So on the left, I've got an example where you've got these 2 squares, a red square and a blue square, and the compositing mode that's being used in saying, use content from the red square and content from the blue square, except where they overlap, right? Omit the content where those shapes overlap. Blending is a slightly different concept. It's saying, all right, when I do end up with pixels from the 2 sources, and they're going to need to combine together in some way, what are the color values? How do the colors from the pixel in source A and the pixel in source B end up combining together? Now, you may be thinking, wait a minute, you said pixels, that's a bitmap concept. I thought this was all vectors. Yes, at some point, the vectors need to get rasterized into a bitmap. And so the blending mode is saying, at that time, when the graphic is being drawn on a surface at a particular size, you've resolved a pixel for one thing and a pixel for the other. How do the color values combine together? So I'll give a couple of examples of effects that the compositing modes can do. If you've used applications such as Photoshop, maybe you've encountered layer masks. Layer masks are similar to compositing. They're saying, I've got a layer that's sitting on top of something else. What of content in this layer is actually going to be visible, or what's going to hide the layer that's below it? So here I've got a red square that's in a lower layer. I've just included that so you can see what ends up being hiding it above it, in a layer above it. In the layer above it, I've got these 2 shapes I'm compositing together, the circle and the shape of the letter A. But the mode of the compositing mode is saying wherever A, the shape of the A, is overlapping the circle, omit that. And so the effect is I end up punching a hole through the circle that's in the shape of the letter A. So you can see the layer underneath it, right? That's not something that, if you've done any font development work, that's not something that currently can be done in fonts. So it was an important capability to be adding. The second thing, it's also, again, similar to if you've worked with layer masks in something like Photoshop, maybe you've seen that you can fill a layer mask with a gradient, And the effect of that is, like if I go from if I'm basically doing an alpha mask as a layer mask, I'm going from fully opaque to fully transparent. And that's a way of making something fade away. And that's what I'm doing here. I've got this green rectangle again in a lower layer. And so we're seeing when I do this composition in a layer above it, which parts of the green rectangle show through. And so I'm gradually fading away that blue circle, right? So some really significant capabilities that we're extending the original color format with. And as I mentioned, another aspect of this is integration with other parts of the font technology. And we've mentioned variations. And so, so anything where it makes sense to be variable, the Color V1 format is able to integrate with variations. So here in this example, we've got the stop offsets in the gradient definition being variable. And as you choose the different variant of the font, you're changing exactly how that gradient ends up, where the color stops actually position. Okay, so that's a quick overview of capabilities that we've added in the format. Let me talk a bit about where things are at in terms of spec status. So I didn't mention earlier, part of my job at Microsoft is that I maintain the OpenType font specification. And so first off, we've already got the next version of OpenType. The key changes for Color V1 published as an alpha for public review. So that's been posted on Microsoft's site for some time now. We're also been, and I'm in progress of advancing to beta with a view to doing the OpenType 1.9 release in November. We've also been interacting with ISO, which has, so there's an ISO standard that is the equivalent in ISO of OpenType. And so we've been working with ISO to get revisions to the OpenType, to the ISO standard to support the new formats that we're defining. So now we're going to switch to Dominic's segment. So Dominic works on the Chrome browser, and with that has been working on the Skia library that's used for graphics, and also the FreeType library that's used for text display. So we're going to switch now to the video segment where Dominic's going to talk in more detail about that.
Hello, my name is Dominic. I work on fonts and text rendering in Chrome. Unfortunately, I can't attend the conference in person today. That's why we're doing this segment as a video. What I would like to show you in the following is Color V1 is already a reality. It's something that you can experiment with in your browser, and it exists in other open source software implementations. How do you get to experimenting with Color V1? The Google Chrome Canary version is a preview version of Chrome that you can download and install on your computer, and then you can experiment with Color V1 in this particular preview version of Chrome. To download it, go to google.com/chrome/canary. And once you have it installed, go to the Chrome flags page and enable Color V1. Then for testing with Color V1 fonts, you can use a variety of options. One option is to go to the Google Fonts GitHub repository, where we have color fonts available for downloads. These are experimental builds that are part of this repository. Or you can make your own off of SVG images, as Rod can explain. Or you use the example Noto color emoji builds from Google Fonts. I would like to show you what that looks like in Google Chrome Canary. So here we have Chrome Canary installed. So if I go to the Chrome version, you see this is Chrome 96, official build Canary version. Then I go to the Chrome flags page. You can search for color v1 here and switch this flag to enabled. This usually requires a restart of Chrome. For this presentation, I've prepared a demo page. What you see on this page is it loads the color v1 emoji font and it's already active in the browser. To see that this is live, I can insert another emoji here, I can delete emoji, or I can move them around. It's hard to see on the video comparison, but if you experiment with this on your own, you will see the nice sharp contours that the color v1 vector emoji display compared to the slightly blurry contours of the bitmap images. Rod in this presentation will also talk a little bit about how font sizes of color v1 compare to the bitmap version. Let's go back to the slides. At the moment, this is a preview, but when we are ready to make this a part of Chrome's stable version, we can bring this to all Chrome platforms where we ship our own rendering engine. With this implementation, we are independent of the operating system. It's not required for the OS to support color v1, but Chrome can still support it. With the hybrid font stack in Chrome, we decide which font rasterizer to use based on operating system support and font format. We download the web font, then we inspect its format. What kind of color font is it, for example, or is it a variable font? And then look at what the operating system rasterizer supports. If it does support the format, we pass it to the system rasterizer. Otherwise, we choose to rasterize the glyphs based on the open source rasterizer stack. This stack consists of the libraries Skia and FreeType. With the hybrid font stack, we can support color v1 on operating systems where the OS itself does not yet have color v1 support. We will be able to bring color v1 in Chrome to Chrome OS, Android, Windows, Mac OS, and Linux. Support for color v1 is based on software support for color v1 in two open source software libraries. The FreeType software library understands the color v1 table with the new definitions of paint operations that we define in the color v1 standard. It tells you about the clip box for a glyph, and it can extract the information about the colors in the gradient definitions of the font. So we added a set of new API calls to FreeType in order to get access to the color v1 information. Using FreeType, we check whether a given glyph ID exists as a color v1 glyph, and then traverse the remaining information for that glyph in the color v1 table. With this information, the color v1 glyphs tells us what drawing operations to execute in which order. So to draw, while we traverse the information about a glyph, we execute drawing operations in our graphics library, Skia, which is the second part of the stack. In Skia, we implemented the logic to follow these instructions from the glyph in color v1. We happen to use Skia in Chrome, but implementing color v1 can be done with any capable 2D graphics library. More on that later. While we do have color v1 in Chrome, color v1 implementations do exist outside of Chrome already. In addition to the Chrome implementation, we have the following open source projects. A Python-based font renderer called Black Renderer. The Black Renderer is written by Just van Rossum and Samuel Hornes. What's special about the Black Renderer is that it already demonstrates that showing color v1 glyphs is possible with a set of different graphics libraries as a backend. The Black Renderer has multiple backends for Core Graphics, and Skia. The second open source project I'd like to mention here is Swash. Swash is a text shaping and rasterization library in Rust. which does not have a Color V1 implementation yet, but from the issues filed on the project tracker, we see that Swash aims to provide support for Color V1 as well. So I've mentioned rendering color glyphs, rendering Color V1 glyphs, and I'd like to go into a little bit more detail of what that means. We have an implementation in Chrome, and we see that it's possible to implement Color V1 against other graphics libraries. Let's take a look at how rendering Color V1 works in general. Glyphs in Color V1 are described as a directed graph of paint operations. Paint operations can be described as an instruction to execute a command with a graphics library. And directed graph here means that a set of paint operations is executed in sequence. So rendering Color V1 means reading the information about the graph structure from the color table, then walking down that graph and retrieving additional instructions such as the colors and orientation used for the gradients, then applying these commands in sequence using the available graphics library. This can be Skia, Core Graphics, Direct2D, or any graphics library. The concepts in Color V1 are designed so that the operations are available. Here's an example that describes the rendering of a glyph and how changing the graph can lead to a different result. A paint rotate operation is stacked with a paint glyph operation for drawing a star-shaped glyph from a contour in the font, followed by drawing a gradient as the fill for this star-shaped glyph. If we change the graph for this glyph, we can place a different kind of fill there. Instead of just a gradient, we can also fill the star-shaped contour with the content of another glyph, which is the paint color glyph operation. Now, rendering means we walk down this graph of operations and give the 2D graphics library commands to execute these operations. First, we rotate the drawing surface. Then we prepare to draw the star-shaped glyph contour and look for information how to fill it further down in the graph. Here we find the radial gradient instruction. Executing these commands in sequence, we arrive at the rotated gradient-filled star shape. You could replace the paint radial gradient paint operation with a paint linear gradient operation or a paint solid to get a linear gradient or just a solid color instead. Also, instead of just a gradient, you can use other paint operations to paint groups of shapes and all combine them into one glyph image. That's what's shown here. Changing the graph to have a paint color glyph instead of a paint radial gradient as the last operation means fill the shape of the star glyph not with a gradient, but fill it with the image that you get when rendering another glyph that's also in the font. This allows reusing complex shapes as part of other glyphs. So this is a broad overview of how rendering Color V1 works. Let's come back to using Color V1 in a browser for a minute. When the Color V1 implementation in Chrome is released in Chrome Stable, at the same time, we're aiming to fill a feature gap on the web. Content developers have been hoping to be able to detect what kind of technology support is available in the rendering engine. This was a request at the time of variable fonts starting to become available in browsers. With Color V1, this becomes an important topic again, as not all layout engines will support Color V1 from the start. I'm trying to give a preview of what feature detection will likely look at. This reflects part of what is currently discussed in the CSS working group as part of W3C standardization. The current standardization work in progress in W3C provides a font technology feature detection function that can be used as part of the CSS add support syntax. If the browser has Color V1 support, you can use your Color V1 font to provide Color V1 graphical enhancements. In your CSS, it would look like this. Placing an add supports condition using the font technology function testing for color-color v1. If the browser understands this and supports color v1, you place your color v1 font face inside this condition and becomes available as part of your as a font on your page, which you can use in your CSS styles. So this is a likely feature detection for CSS, and let's see what this looks like. And so this would be the declarative version. Let's look at what this would look like programmatically in JavaScript.
And with apologies to
If you need
Dominic,
to detect availability, not
apologies to Dominic, I think we started a minute or two late, so I'm going to jump over. You can do the same thing in JavaScript. So I want to talk just for a minute about how you actually create fonts in the new format, because obviously font creation tools don't actually support it yet, and no design tool supports it directly yet, so are we stuck with a chicken and an egg? So what we see is that design tools that tend to give us SVGs, like, you know, Jennifer might give me a whole bunch of SVGs. Typically, they're not optimized SVGs. They're full of duplicate, invisible, or effectively invisible shapes, degenerate gradients, verbose encoding, pointless metadata. The list goes on. So individual files are not that optimized. So we have a tool called Pico SVG that can take one file and kind of optimize it to some extent in place. It'll end up with only one definition element with only gradients. It'll only have groups and paths. It'll only have absolute coordinates. It'll apply any clip paths. If there was stroking, it'll produce the actual path. And conveniently, it'll end up with a tree where by the time you encounter something that references something, you're guaranteed to have encountered the thing that's being referenced, which is quite helpful. To give credit where it's due, Skia has a library called PathOps that makes half of this possible, so that's awesome. Skia is amazing. So now we have a pile of simplified SVGs that we can try and turn into a font. We have a public tool called Nano Emoji that does that. We just walk through our simplified SVG, which we sort of deliberately built in a simplified way that makes this step easier. And we turn it into a color font. We actually support a bunch of color font formats, not just color v1, because we wanted to be able to kind of compare and see how things landed and confirm that, you know, we said it would be more compact. Well, is that actually true? If I build a bunch of stuff to optimize shape reuse and apply the same logic to SVG, maybe that would be good enough. So you can see if you look at shapes, I just want to kind of show a few examples. There's common colors and gradients all over the place. Designer just produces their shapes, they automatically share. Similarly, I'm going to skip some of the details because we're low on time, but same shape showing up, you know, rotated, scaled, offset, or what have you, will just get reused. And all that's done by the compiler, so you're not asking your designer to tag things or to designate things as being recolorable. It just says, oh, you use the same fill on a shape that can be produced from other shape, just do it. And if we look at emoji in particular, this type of thing is all over the place. Like you look at this guy's sword handle, or even look at these different ones with different skin colors. Like this is massively reused. You add one more ninja, and you basically reuse all of the same parts. Even within one ninja, you're reusing tons of the same parts. So we see this type of thing come up. So the format supports a 2x3 matrix, but we also have specialized versions for very common things, like reuse this at some offset. So we did some testing on file sizes, which I think is probably the most interesting thing. We've published all this. You can rebuild them. You can play with the compiler and, you know, produce it with your own optimizations, which I'm sure you're dying to do. So at rest, as in not compressed for transfer over the web. The first example, CBDT, is what Google ships today. It's about 10 megs. The next three are color v1 using different formats to represent the outlines. It ends up quite a lot smaller, which is nice. Then we have a bunch of different variations of OTSVG. The best one we could come up with is if we use our SVG simplifier, that's Pico SVG, so OTSVG, Pico SVG, and then use the SVG Z format, which means that it's zipped inside of the font. And that's nice. I mean, all these are looking within the realm of being usable. Twimoji has much the same results. They have an open source set, so we tested with those as well. There is a bit of a nuisance, though. When we want to transfer these over the web, we typically compress them with WAF2. And the result here is that color v1 compresses nicely. You get small, compact fonts both in flight and at rest. But what we observed for SVG is you kind of have to choose a winner. If you applied zip to the SVGs inside the file, so you've got SVGs in there, the file that's resting on your disk will be small, but then when you waft to it, waft 2 won't be very effective. If you have inflated SVGs in the file, then the file at rest will be massive, but it will waft to quite nicely. So that's a little bit of an unpleasant trade-off to have to make. And Twimoji shows the same patterns where color seems to be compact in flight and at rest, and OTSVG makes us kind of pick one. So just to briefly summarize, it seems like our binary vector format is compact in flight and at rest. It gives tons of flexibility for a compiler, like we're far from done looking for opportunities for our compiler to make this thing smaller, to better reuse shapes, etc. And all of it's public, open source. The spec has been in the open. We've got great feedback from the community. The tools are open, the compiler's open, the sample fonts are open, and indeed the emoji assets are open.
Okay, to wrap up, just want to quickly talk about, what are the prospects for this as a new format. Earlier, I came up with a set of criteria for comparison, and we've already talked about ways in which the existing formats all have limitations. And so how does Color V1 compare? For authoring design apps, well, you've got the same set of capabilities for a designer as for OTSVG, because they're using tools like Illustrator or Figma. The graphics capabilities are a significant set of capabilities that we've provided. We've got variation integration along with the graphics capabilities, and that's something that none of the other formats provide. And we've got the most compact file sizes with all of those graphic capabilities. So the last thing is, well, it's new, and will it take off? Let me come back to this set of comparisons, criteria. Graphic capabilities, they're there. The format is extensible. It integrates well with the rest of the OpenType format. It's relatively easy. I think we can say it's easy to integrate. The Black Foundry project kind of demonstrated that for us. They came up with their implementation very quickly. We have very compact fonts. Is it going to be good for font developers? Well, that's really going to depend most on, will it work everywhere? And that's the biggest open question. How widely will it be adopted? Google's already supporting it. Microsoft has plans to support it, though I can't comment specifically on product timelines. Will others support it? That's still something to be determined. There are future ways that we have, ideas that we have in mind for continuing to add capabilities. We want to add some filter effects, particularly things like blurs, so you can do drop shadows. Other capabilities. The one thing that's not variable is the specific color values, and so we have some ideas. Well, maybe if that's something that designers can leverage, we want to add that capability. So those are the prospects. On this slide, we've got a set of references to documentation that you can look to if you want to find out more. Thank you. I don't know if we've got time for questions.
We don't have time for questions.
Okay.